Hi, welcome. I will briefly introduce you to the latest update of the 53 North Array. The 53 North Array is an array of moorings that's being installed at the so-called exit of the Labrador Sea. And we are operating that array since 23 years now. My special thanks goes to Patricia Hanman, Martin Fisbeck, Jürgen Fischer, and the Maria's Merian 94 Science and Chips crew. The 53 North Array is being set up as an array of up to 7 moorings currently. These 7 moorings are designed in a way that they measure all 3 branches of the North Atlantic deep water in the deep western boundary current. These 3 branches consist of the locally formed Labrador seawater, the Northeast Atlantic deep water, and the Denmark Strait overflow water. We are interested in the deep western boundary current because this is a major conduit of the deep limb of the Atlantic meridional overturning circulation. It also is a primary pathway for the meridional freshwater oxygen nutrient redistribution. The array itself from the 7 moorings is also part of a very impressive international coordination effort, which is called OSNAP, the Overturning in the Subpolar North Atlantic program. And that consists of a couple of other mooring arrays all across the subpolar gyre that in total is able, this array of moorings is able to estimate the overturning, real overturning circulation in the subpolar North Atlantic. What is shown here is the timeline of the array, starting in 1996 with the first cruise, and then in 1997 the first installation of the array started. That goes now up to 2022 when we plan to have our next servicing of the moorings. The black lines actually indicate the water depths at which moorings or a mooring has been installed. So for example, from 1997 to 1998, there was at 1,100 meter water depths, a mooring 815, and then there were 3 other moorings. One was actually serviced in late 1997, beginning 1998. And that goes on here. You can see that since 2014, we always have 7 moorings installed that measure continuously in 10-15 minute resolution the boundary current properties and also the flow strengths. You can also see that there are certain periods where there are very few moorings, only 1 mooring in certain periods, and of course the estimate of the overturning transport, or the transport in the deep western boundary current, I have to say, is limited for this type of periods. You can also see on the top here the many different cruises. 16 cruises so far have been conducted in order to service the mooring array. Typically, we have deployment periods of about 2 years. This is now from our latest redeployment. That's a typical COVID cruise, I would say. The cruise started and ended in Germany, in Emden. And overall, we had about more than 2 weeks just to go to the other side of the Atlantic, to the Labrador Sea, where we had, after a short stop in St. John's, we started to redeploy the moorings in the 53 North Array, which is depicted here also in more detail, and also of a few moorings that belong to the OSNAP array in the northern part of the Labrador Sea. These are some impressions from the recent deployment cruise. You can see here the many different instruments. We deploy aquadops, microcats, and we have a telemetry system for one of the moorings that sends us data back home in real time. Then there are here typical anchor lounge, and you can also see, of course, the Maria's Merian. We had very nice weather at most of the time, so we progressed very well, and we could do mooring deployments as well as also a couple of calibration measurements before we recovered the moorings, we actually could do calibration measurements at the mooring sites, and then we calibrated the mooring devices attached to the CTT. What we're using for the mooring design, actually, it's a MATLAB-based integrated mooring package that's around. And that package actually calculates the design, but it also calculates different other parameters important for the deployment, like the launch and the static tension that will act on the mooring wire when we launch and also when it's later in the water. It simulates subduction, so depending on the observed flow profiles, current profiles, it can simulate how the mooring will behave. And we adjust and fine-tune the mooring according to these calculations. Just two short mentioning of the results. One is, this is shown here, the hydrographic changes at the deep convection region. It's monitored with one mooring, and then from the central mooring of the deep western boundary current 53 North Array. So what you can see is that there have been a peak in warm temperatures in the upper layers, at least, and also in the deeper layers. This is a temperature distribution from 1997 to 2020, actually. So what you can see is that there is quite a bit of, was warming until, say, 2010, 2012, and then deeper convection started again, and that also has been communicated to the boundary current. And this is one of our main interests, to understand better what the communication, how direct or indirect the boundary current fields is being fed with deep convection information, or if there even is a deep convection in the boundary current, which doesn't look there is. Another update here is on the deep western boundary transport variability. This is shown here, North Atlantic deep water transport, which is for us here 400-meter depths to the bottom, integrated across the array. This is a mean distribution here of the flow field, and the mean transport is about 32 swirl drops. And you can see that on top of this means transport, there is some longer term variability, multi-annual variability. And what is shown here, actually, this gray contours are 5-day estimates of the transport from the moored array. And then this is a 1-year running mean on top of it. And that 1-year running mean shows us that there was and still is interesting multi-annual and even longer variability. Thank you.